Let's work on deriving the continuous compound interest formula. Before we start, we should be given some values. So let's let I equal the interest paid, A be the final amount, P be the principal that we're starting with, R be the annual percentage rate written as a decimal, N be the number of times compounded per year, and T be the number of years for time. We're given two formulas. We are given the compound interest formula of A is equal to P times 1 plus the rate over the number of times compounded per year to the power of the number of times compounded per year times the number of years. We're also given the definition of E as a limit. So E is the limit as x approaches infinity of 1 plus 1 over x to the power of x. And so to get started, we're going to start with the given the compound interest formula, which gives the final amount after the interest that is compounded n times per year. Here, P is their initial investment, where R is the interest rate, N is how often interest is compounded annually, and T is the time in years. Continuous compounding means interest is added infinitely often, so we will take the limit as n. The number of compounding periods goes to infinity. To find the formula, we take the limit of the compound interest formula as n approaches infinity. This gives us the formula that we'll need to derive. Since P is a constant, we're able to factor it out of side of the limit. This leaves us with the limit as n approaches infinity of 1 plus r over n to the power of nt. Our goal is to simplify this expression to evaluate the limit as n becomes really large. Our expression of 1 plus r over n to the power of nt is kind of tricky because both our rate and our times that we are being compounded are both in the base and in our exponent. So to simplify, we will let x be n over r, so that 1 over x is the same as r over n, which is the same as n equals xr. This will be useful as n is approaching infinity. X will also approach infinity because our rate is fixed. This substitution will transform our base. I'm going to say that 1 plus n over r into 1 plus 1 over x, which resembles our definition of E, where the limit of x as it approaches infinity of 1 plus 1 over x to the power of x is E. And we're starting to get closer and closer to what that looks like. I'm going to rewrite my exponent using the exponent rule. And this is starting to help us recognize that familiar pattern, and I'm actually starting to see E. At this point, E has been given, so we'll use our last given fact that the limit as x approaches infinity of 1 plus 1 over x to the power of x is in fact E. Replacing that limit with that given using substitution, we have P times E to the power of RT. This is our final result. The use of E reflects our exponential growth as interest is compounded at every possible instance, unlike when we are discrete compounding.